This is questions 22 and 32 from exercise 8.1 in Project Maths 2. We have to change each of the formula in the questions to express the letter in square brackets in terms of the others. So we'll start with question 22. We have 1/2 multiplied by 3a plus b is equal to 1/3 c, and we want to get a on its own. We could clear away our half by multiplying both sides by 2, which will leave our fraction over here, but we'll make that manageable. But what might be easier to do is to clear away all of our fractions at once. In order to do that, we've got to multiply both sides by the lowest common multiple of our denominators, which are 2 and 3. And the lowest common multiple of 2 and 3 is 6. So I'm going to multiply both sides by 6, in which case we get 6/2 times 3a plus b is equal to 6/3 times c. Now 6/2 is 3, so we end up with 3 times 3a plus b, and 6/3 is just 2, so that's equal to 2c. Now from there, if we want, we can either multiply our bracket or move our 3 at the very start, so I'm going to move our 3, so we're going to end up with 3a plus b is equal to 2c over 3, because on the left it was a multiply by 3, so when we move it over to the right hand side of our equation it becomes a divide by 3. And now from here we're going to move our b over, so we get 3a is equal to 2c over 3 minus b, and now we just need to get rid of this multiply by 3. When we move that over, it's going to become divide by 3, or it becomes multiply by 1/3, which is the same thing. So we're going to get a is equal to 1/3 times 2c over 3 minus b, just like that. And that right there is a perfectly acceptable solution to this. Now alternatively, from this point just here, we could have done something slightly different. Or we could have multiplied our bracket out at this point, in which case we would have got 9a plus 3b is equal to 2c. And then we would move our 3b over, so we would get 9a is equal to 2c minus 3b. And then all we need to do to get a on its own is what's going to bring our multiply by 9 over, in which case we get a is equal to 2c minus 3b all over 9, like that. Which again is a perfectly acceptable solution to the question that is posed above. Either one of the answers that I've given would work just fine if you were given this question. Alright, let's take a look at question 32. In 32 we've got 1 over u plus 1 over v is equal to 1 over f, and we want to get f on its own. Now what would be far easier to do at this point would be to clear away all the fractions. And to do that we're going to need to multiply each of these terms by a common multiple of u, v and f. So what we're going to do is we're going to multiply every single term here by u, v, f. Just those three terms multiplied together. So we're going to get uvf over u plus uvf over v is equal to uvf over f. And now we can do a little bit of cancellation. So our top has got a u and our bottom's got a u in our first fraction, so they will cancel each other out. And the top has a v, bottom has a v, and our second fraction, and then our f's are going to cancel our last one. So we're left with vf plus uf is equal to uv. Now from here we're looking to get f on its own, and we have it in two terms. So we're going to have to factorize. So if we take f out as a factor, then inside our brackets we're going to have v plus u, and that's still equal to uv. And now we just need to bring our brackets with v plus u over. So on the left it's multiply by the brackets, so on the right it's going to be divide by. So we're going to get f is equal to uv all over v plus u. And that is that.